So hi everybody, thank you for coming. So today I'm going to talk to you about how to use half-cooked elephant in order to turn people into profit, or more precisely about semi-supervised learning on Hadoop to understand user behaviors. So briefly, my name is Florian Dueto, so sorry for the ugly French spelling. I'm the CIO and founder of Dataiku. Basically, we're a software vendor. We're building a studio, a tool for data scientists with data preparation, machine learning, and visualization. And lots of our customers today are using it to do data mining on the weblogs for classical use cases such as recommendation, targeting, ranking, and you heard probably lots about this kind of use cases. But today, I'm going to try to talk to you about some new experiments they're doing about monitoring the behaviors of people on their website using our tool. So the key question at the beginning of the talk is, what does matter on a website? What does really matter is in terms of metric on your website? What do you need to look at? And depending on who is answering this question, you usually get very, very different answers. A CIO will talk about number of unique visitors and about revenue, and people more like a product manager or an editor on a website will focus a lot on number of comments generated by users, time spent on the website, and so on. And also, depending on what kind of business you're in, you would focus more on, like, for instance, a newspaper or a news website would focus on number of articles seen on the website, time spent, and in terms of business metric, subscriptions, whereas a search engine or a search website will focus on click ratio on the first hit and advertising revenue and so on. But in all this kind of business, there is a kind of a myth of a hidden metric, a hidden variable that would help a lot in terms of understanding all those metrics altogether, which is user satisfaction, like the hidden proxy variables that everybody would like to know about. So the question is, how can you actually try to get a grasp of the satisfaction of your users on your website? And actually, when you try to do that, you've got at least two big problems. The first one is that when you've got a large website with more than, like, let's say 1 million users or visitors per day, you usually already have a very diverse audience and very, very different pathways on your website. You would get, like, today between 10 or 20% of your traffic from social networks, possibly with people that come to your website and don't know why, don't know whether, and do not realize that they are on your website. Actually, they read your content, but they don't know that they are on your website. They just come from Facebook randomly and got to your website. You've got people coming from search, but you also have most probably already existing users that come to your website very often and almost every day. On a news website, you've got people that would focus on a very, very specific topic, would go straight to the sports section just to get the result from the Champions League, and so on. So at the end, when you look at metrics, like time spent, number of page views, if you aggregate all these kind of behaviors together, you usually don't really get a grasp of what's happening on your website, because you're averaging something which have very, very different patterns and a huge variance, actually, between all those behaviors. So a solution for that, a quick one, is to build what we call segments, meaning trying to segregate people by behaviors and just have rules in order to segregate these segments. Like usual one would be to segregate people that come often to your website, put them in one bucket, and the other one, put them in another bucket. Other strategy would be to segment people by the kind of channel they're coming from, social, search, genuine traffic, and so on. So that's one strategy, and actually, in lots of cases, it works pretty well. A second problem you have when you want to get a grasp of user satisfaction is that you need to actually choose one metric. And here, actually, well, many metrics can be chosen. You can look at page view, whether people, ratio of people that come back from one day to another. You can look at transformation ratio and so on. And if you've got lots of mathematicians and creative people in your company, you could find many ways to create metrics out of the statistic of your website in order to get a better grasp of user satisfaction. And the thing is that at the end, you got two kind of issue with this kind of practice. The first one is when you are building rules in order to build segments, usually they are hard to maintain, and on the long term, you kind of miss what's really happening in terms of behavior on your website, because it's very hard to maintain on the long term, like 20 or 30 groups or segments of people or behavior on your website, and that it's difficult to make people agree on a single metrics. Typically, business people and tech people wouldn't agree in terms of what is the metrics that is the most important to follow on the website. Okay. So now let's take a big step back and talk about semi-supervised learning. So semi-supervised learning is a term which was quite hype a few years ago, and basically it describes situation where you've got machine learning problems, where you've got some of the data which is labeled, and you would want to predict something out of these labels and use it as a trained data. But most of the data is not labeled at all. And you want to mix all this information together in order to build a better model. Just let me give you a quick example. So semi-supervised learning is very commonly used in natural language processing, and specifically in machine-based translation, because when you're doing machine-based translation, you usually have a quite small corpus of text already translated, where you can match, let's say, French in English, a sentence in English, and a sentence in French, and use it as a labeled data. But you've got lots of information, lots of text, in either French or English, that is unlabeled, meaning not translated at all. And so state-of-the-art unsupervised learning, machine translation, would use unsupervised learning technique, meaning would use both the whole text not translated and translated text in order to get better performance. The analogy with web traffic that we used is that when you're looking at web traffic and web session and journeys, you've got lots of unlabeled data, meaning people moving along on a website that you don't really know how to characterize. And on this unlabeled data, you've got weak signals of people doing something particular, moving to subscription, giving a feedback, and so on, that you want to use as labels. That's the analogy. But I will come back to that later on. Generally speaking, when you have a semi-supervised learning problems, you've got different kind of approach. The more elaborate integrated approach would use common algorithms for labeled data and unlabeled data, where basically you try to use unlabeled data to fix the hyperparameters or to use as a cost function for your supervised learning problem. But in most actual solutions I saw in natural language processing or whatever using semi-supervised learning, you end up having kind of an ad hoc approach where you use an unsupervised algorithm, then a supervised algorithms together in order to build a solution. So just to give you a grasp of what it means to do unsupervised learning, here imagine you've got a data set. Labeled data are the color dots, the color boxes, and unlabeled data is in gray. To simplify, when you're using a pure supervised learning method, you would build a kind of models on your data that would end up by the model would look like more or less like a circle around the data on which you trained. But you wouldn't use unlabeled data. And unsupervised learning approach use unlabeled data in order to reshape kind of the models and better get a grasp of the underlying structure of the data. And so at the end, it's an opinion that this model is better than the other one because you better capture the structure of the data. So, but now let's get back to mining weblogs in practice. So in terms of mining weblogs, the approach we had was in 3 steps. First, preparing data. Second, build clusters and use them as routes for behaviors. And third, create predictive user satisfaction metrics. So in terms of data preparation, so data preparation is actually in most cases I saw the longest part of the process. It's in sub-step. It has already different sub-steps. And the goal is to get from raw data, meaning the raw web tracking logs with every detailed user behaviors, to actual vectorized numerical data that you can use for machine learning. The first step is actually pretty simple. It's about getting from a log, where every page view or event is 1 row, to sessions, meaning something where you've got 1 object per user session on your website. So here it's pretty simple. You can do it in Hadoop with Pig. It's a group by. And the main trick I use commonly is to do it early stage in the pipeline in order to reduce the size of my data, and to use the structure Pig arrays in order to get and keep the list of events of a session properly, early stage. The second step of data preparation is a funny one. It's just to use web-based information, every technical information you've got in the weblog. The most common one is IP address and timestamp. From the IP address, you would get the city, the location and the city of your user, and a time zone. From the timestamp and the time zone, you can know whether the guy was browsing your website during night or day, for instance, which is useful because most people don't use the web the same way during night or during the day. Well, I don't use the web the same way during night and during the day. And in order to do that, you've got 2 options. One that I was using a lot was just using Pig, Hadoop streaming with Python, and useful libraries to do GeoIP and time zone and so on the proper way. It's actually quite complex to package it, so we also package it in our product in order to be able to do it more quickly. And at the end of this step 2, you already have tabular data with session and additional variables that you can use for machine learning, but it's not enough yet. Step 3 of data preparation is to build variables from the session itself. So simple variables are like the number of page views in the session, the time spent in the session, stuff like that you can imagine. I could write I could have given you some Pig script examples, but it's very common and very simple actually. The key thing is that usually these variables do not help that much. You have to use them, and they do not help that much because they don't help to differentiate between different behaviors on the website themselves. If you just use this kind of variables, you can end up with clusters that do not separate really people that come to your website for different reasons. And in order to have interesting variables in your data, the next trick is to use something called sequence mining. So sequence mining, again, is something used a lot in natural language processing. The main idea is that when you are looking on a sequence of events, looking at the frequency of events themselves in order to know something is usually not enough. It's far better to look on the frequency of n-grams of events, meaning the sequence of events themselves. So for instance, when you want to know whether a text is in French or in English, it's usually enough to just look at how frequent are the sequence of characters within the text, meaning A, U, I, O, E, and so on. And the frequency of this sequence of events is very discriminative of a language compared to another. So here, the idea is just to apply it to a web session itself, using as a tokens the different URLs or events seen in the session. Actually, to make it work we had 2 tricks which make the solution very useful. The first one is to add as virtual token the source or referrer of the data, meaning where does the user was coming from, like Google or a different referrer. The other one is to have 2 levels of tokens, one where we keep most of the information about the URL and the past navigation, and a second level where we mostly keep the first pass of the URL or the category information on your website. So again, you can use Hive and existing ngrams UDF in Hive and other UDF in order to build metrics. The most common one would be the LLR, least likelihood ratio, in order to know which ngrams to keep and select in your model. And basically, it's about writing an Hive query where you create an ngrams and then you compute least likelihood ratio and use the result in order to filter which ngrams you want to keep in your data. Ngrams being a sequence of meaningful events on a user session. Step 4 of data preparation is to compute user-level data. User-level data is information that you aggregate over several sessions together and give lots of information about the user itself. The most interesting variable here, usually used, is the number of distinct days that the user visited on the website in the last 30 months, because it's a very stable measure across different use cases, and it helps discriminate between people that come very often to your website and those who won't. And then at the end of this step, you're more or less ready to do to start doing some machine learnings. So there are lots of different options for doing machine learning in our own Hadoop, and comparing all those options altogether is out of the scope of this talk. The key remark here is that when you are doing this kind of stuff, when you remove robots, you remove unmeaningful sessions, you keep only most meaningful ngrams and so on, you end up having a pretty small data at the end for machine learning. Meaning even if you got not a very large website, but a pretty big website, you end up having something which fits in RAM of a single machine. So at the end, something which we do a lot is just using Python out of Hadoop in order to get the machine learning data and use existing open source library in Python. We use Scikit-learn a lot in order to build the clusters. Something I really like to do, because actually I describe you this process as step by step, but in practice it's far more iterative and so on, is to have a very productive environment where I can just do the data preparation and try a new cluster and so on in one step with one keystroke. And in order to do that, I don't want to have to get some data out of HDFS to my local machine and so on, just because it is not productive at all. So here you can use lots of Python library in order to get the data directly from HDFS as a data frame in Python and start working on it. And it's even if it does not make sense when you want to do it just once, it usually makes sense to build yourself a productive environment to do these kind of things, because you will have to iterate, and whatever machine learning stuff you do, you will have to do it again and again in practice. So just to give you, so now imagine you've got session data. So here I use a 2D projection, but in practice you would like have 40, 50 variables to describe a session. So basically first step is that we build clusters on the data. And then a trick that we use, which in practice seems to work very well, was to take a number of samples, usually like 2,000 samples per cluster, from the clustering itself. And then the next step of the process is to ask someone meaning the product manager or the editor of the website, to label those clusters using the samples, meaning we show him the sessions themselves, what the user from the samples were doing, and we ask him to just say, oh, we want to describe this behavior, if it makes sense to him. It's actually quite stupid and simple, but, and so for instance, he would say, this guy was searching for a specific topic, or this guy is most likely interested in sport, or this guy really likes to comment, it's very, very engaged users, and so on. And then you end up having clusters with labels. The key part, in fact, of this process is the difference between this slide and this slide. There is a color point here. Oh, yeah, sorry, you don't have a very good contrast. I should have used different colors. But basically what can happen is, what you want to do is that you can keep some unlabeled samples in order to show them to the product editor or product manager or editor afterwards to check whether he labels new behaviors, new web sessions the same way than he was labeling it before. Because in some cases he would say, he would kind of change his mind and the labels wouldn't be very, very consistent. And at this stage, what you have to do is either tell him that he's nuts and that he has to just focus and give consistent labels and so on, or most probably you have to change your clusters, your variables, and iterate back in order to have a clusters where the editor or product manager can label stuff consistently. Then next step is to use supervised learning on the samples in order to extend the existing labels to all the sessions from your weblogs. Again, in order to do that, you can just use Python and Scikit, just because your trained data is actually quite small. If you've got like 20 clusters with 20 samples, you've got only 400 samples. In practical cases, because we had to make the labels several times, we were working more like on a 1,000 or 2,000 sample of sessions. And here, a common trick which works well in practice is to just use Python and Hadoop streaming with a serialized model in order to apply it quickly to all the sessions. And at the end of this step, well, basically you just have all the session labels with behaviors, like search for a specific topic, or newcomer from Google News, or really, really engaged users that you want to focus on, and stuff like that. And you can focus, you can build, and you can just compute your metrics using these behaviors, which is already better and interesting. Next step is to actually build user satisfaction metrics. So in practice, we saw two different kinds of metrics. One was more future-based metrics, meaning try to infer user satisfaction by looking at future events, meaning subscription 6 weeks or 3 months later. And it was very, very useful, for instance, with people in subscription-based models. Or another one with expressed opinion, meaning using actual feedbacks from real users in order to infer user satisfaction of all the users. So when you're working on feedbacks in practice, it means that you've got session data from a few million sessions. You've got a few thousands of actual feedbacks. And actually you make a pretty strong hypothesis, which is that people with similar navigation patterns have similar user satisfaction levels, independently from the fact that they expressed a feedback or not, which is actually a very, very strong hypothesis. But in practice, we just made it. And so what we do is that we use feedbacks from the users where he expressed something, and usually it's a binary feedback like I'm happy or I'm not happy. I gave a very negative feedback about something not working as I wanted on the website, and use it in order to infer a scored satisfaction for all the users. in practice, what we got at the end was a satisfaction score for all the session that we could use and aggregate at the level of behaviors in order to get satisfaction score on the behaviors themselves. Last trick is about looking at the data on a daily basis. When you look at this kind of data on a website on a daily basis, you usually get a lot of variation in the data itself. So a very, very common trick that I guess lots of you know about is smoothing, meaning doing a moving average or exponential smooth moving average in order to get more interesting data to look at. And the reason to do that is in practice, when we were showing the red line to people, meaning to product manager or editors, they would usually get scared a lot because they were looking at this metric very, very often because we were doing the project. So we needed to kind of smooth the metric so that they kind of get a better understanding of this metric itself. So again, you can do this in Hive. And in fact, we've put a useful UDF on GitHub to help you do that, that you can use in order to build from a time series which is not smooth, time series over your data. And so just to wrap it up, at the end, you can get dashboards where you follow people per behavior and get their user satisfaction per behavior. And if there is just one takeaway from this talk, it's that in practice, instead of looking at 10 different metrics average over all your audience, I'm pretty sure that it's better if you can look at one metric for 10 groups within your audience. And it's an hard process to do so, but on a large website with diverse audience and already a mature audience, I think that's it's on the long term the way to go. And I think I still have time for questions because I went pretty quickly. Yes? The gray bots or dark bots, the famous one. In practice, because we are working with mature websites to do so, they already had a list of IP address of people that they would blacklist for bots. But an interesting finding was that one of the clusters in this case was actually a bot. And the behavior of a bot was very, very simple to find when you were looking at as a human, because he was basically trying to enumerate all the pages in a specific order. And so the sequence mining helped a lot just to filter out this bot. And at the end, the bot was one behavior among the others. Yeah, that works only with bots that don't mask their IP address and keep a cookie and so on. So if the thing is, if your bot does not, if you have bots that use botnet and don't keep the cookie and so on, the next step you would have to do would be to cross-match JavaScript-based traffic to the web server traffics, which is another problem, and to filter that out before. But that's a complex issue that we had to solve.
I guess in that case, my next question is, how big a problem do you think it actually is?
I don't know on a large scale on the internet, but it was funny to see that in practice, in real life web traffic, you had bots which were not using botnet, meaning either mostly the same IP address over the same day and keeping a cookie and so on, and that people were using to actually trying to scrap a whole website. The thing is that today, just because of how a website is built, people would tend to keep a session cookie on their bot, just because the website wouldn't work as expected without a session cookie. And so I think to some extent it helped limiting this effect. Yes?
Are you using this information about users while users are on your website? So are you addressing different user who likes fonts than the user who likes the comment, for example? Are you building custom versions of your website depending on this?
It was not the scope of this kind of projects. We had other customers that build recommendation engine, so of course it's about personalization, but here it's just, we are talking a lot about using big data to get into action, and not just insights, but sometimes for big websites, having insights at the right level of information is already an art problem.
There are many different sequential mining algorithms.
Yes.
Which one do you use in particular?
Here we just use the LLR metrics on n-grams and different length of n-grams with different level of abstraction, meaning using the whole pass or just the beginning of the pass as a token. And we had imagined using more elaborate Markov-based sequence mining algorithms, but in practice in practice, it was enough in the cases we saw to just use LLR metrics to select the n-grams.
Yeah, but it's brute force, right?
It's brute force, yes. And to some extent, you have to validate the limit, meaning the limit you put to the LLR metric by end.
So what value for n?
Sorry?
What value for n in n-grams? Even 5 grams or 10 grams? Or?
It was like 3 grams or 4 grams. In practice, with referrer information usually as a first token.
So you have to come in from Google or
Yeah.
Searcher or give around.
Yeah. In fact, using this information as a token for n-grams is actually one of the tricks we discovered during I find the most amusing one. Yes? So to do the k-means, we use the unlabeled data only.
So the first pass is completely unsupervised.
Yes, the first pass is completely unsupervised. But that's the thing which is, talking about semi-supervised learning for this can be seen as, it could be discussed because we don't use actually an integrated semi-supervised learning algorithms. Using buzzword, I could also talk about active learning, because what we were doing in practice was to select the sample using unsupervised, and possibly if the labeling was not consistent, redo the clustering with more variables, but manually, meaning it's yeah.
Did you look at any correlations between the clusters and the preferences for the people within the cluster for certain categories within the website? So do you have findings where you say that the really quick browsers are also the people that only read tech news? Those kind of things.
Actually, that's a good question. The thing is that in practice, before doing that, I was believing that user agent information was very, very important. But in the cases I saw, it was not the case. Probably it also depends on the countries and stuff like that. What was very discriminate was between mobile users and web users, where they were just not using the website the same way. Specifically on a newspaper website, mobile users were focusing a lot on very, very specific sections of the website. But yeah.
Do you think you can assign a user to a cluster halfway through their session? How much
Yeah, I think you could do it online, but in practice, in the cases we saw, we are not talking about e-commerce here. Meaning, when you're doing e-commerce, you've got transformation metrics and ratio which are on a short-lived funnel, so you're thinking one way. Here, it's more about people doing subscription models and stuff like that. So they tend to think about their users on the middle to long term. So I don't think, I'm not sure how this would be used. But that's a good question. Yes?
Another one about the k-means. You drew a picture where you had, as a result of clustering, circle-shaped clusters around centroids.
Yep.
And then the next pass where the circle shaping differed.
Yep.
And the boundaries were changing.
Yep.
How do you obtain that result? It wasn't completely clear to me.
Okay. Yeah, you would obtain this result using semi-supervised learning, using not k-means but Gaussian mixtures, and where you would fit the parameter of the Gaussian mixtures using the unlabeled data in a classification. In practice, we still used k-means because it was simple enough for our case, and so the kind of cluster we had were circles in practice. Yes. Yes.
Did you use any normalization or cleansing technique on the raw data before moving to model?
Any kind of normalization? Yeah. Oh, yeah. Yes, we were normalizing all the numerical values in order to reduce variance and so on before applying k-means. And also doing some ACP on some of the variables before applying k-means. But I did not elaborate on that. To be precise, in fact, we were using ACP on a sample version of the data because ACP is pretty costly compared to k-means itself. So it wouldn't scale that well using just one server and Python. Any other questions?
Are you
Yes.
gathering some data directly from the users? Like, are you looking at when they are registered users and they subscribe to like certain topics or pay for some services? Are you using this information like directly even from the users for the supervised part of learning?
No, actually for the supervised part, meaning user satisfaction, from one customer was using subscription itself, so the subscription event itself, just to build a user satisfaction metric. And the other one was using internal feedbacks on his website. So, but it was the only information actually used directly for supervised learning. Other information is used as a feedback to the product manager for labeling. The thing is that on large websites like that, having proper tag information and accurate events is a challenge by itself. And so get information from forms filled by the user is sometimes not doable. And because just you need to have already have history when you begin working on the data, so you don't want to engage in a process where you have to change the way information is collected on the website before starting to work. Otherwise, you don't do anything.
Yeah, I was more thinking of like registered users who is subscribed to sports newsletter and you know he's interested in sports because he's subscribed there and he said he's interested in sports, so you could use this data point as part of some supervised learning.
Yeah, okay. I understand. We didn't add any customer with per topic registration mechanism on the website.
And do you think this would be useful or not really?
Yeah, I think it would be useful. It could be useful to suggest to people to register to a particular newsletter or stuff like that. Last question.
Are you just creating one for the clusters who will use them, or are you, I don't know, every week or every month you are creating new clusters? As I said, one for all.
Today, with one customer, he more or less rebuild his cluster every 2 months or something like that. So I don't have a very precise frequency for that, meaning he did it 3 times. So it's a good question. I don't know in practice. My intuition is that it's not something that you would do on a weekly basis, but it's something that you would do at least 2 or 3 times per year, more or less. But you wouldn't want to do it too often because the goal here is to be able to follow changes on your website and what happens when you do a release. So you don't want to do it as often as you do a release. So again, it depends on how often you release on your website, which is another interesting topic, which was not covered by any statistic or predictive model yet, but in terms of performance, but it's another topic, yes. Thank you.